So we've talked about molarity quite a bit with solids and with grams, but we've talked very little about molarity with solutions. So today we'll talk just a little bit about molarity with liquids or with aqueous solutions and how we use stoichiometry and the steps that you've already learned to do stoichiometry with a solution. This applies a little bit better to sports drinks and will kind of help complete our unit as we finish up here. So we've got here a fairly simple acid-base equation. Hydrochloric acid and sodium hydroxide yield sodium chloride and water. And the question that we're asked is what volume of 1 molar hydrochloric acid is needed to neutralize 50 milliliters of 1 molar sodium hydroxide. So we're given a little bit different information here, but we're given a volume that we start with, and we're given two concentrations. And your concentrations will act a little bit like the molar masses that we were using earlier. If you think back to that table, we would have done grams to moles to moles to grams as we went through those steps. Well, now we're going to change this just a little bit, and instead of doing grams to moles and ending with grams, we're going to use volume or liters. And we're going to end with liters or volume. So our steps really remain almost exactly the same. It's just that we're starting and ending with a volume instead of with a mass. So our step to get from liters to moles, we're going to need the concentration. I'll abbreviate CONC there, and that is in molarity, which if you recall is moles divided by liters, or very similar to grams per mole if you think in terms of molar mass. Now we've got moles per liter, and I'll show you how to put this into the equation. So we're asked what volume of 1 molar hydrochloric acid is needed, so that's what we want. The new stuff is going to be HCl. That's what we are looking for here, and is needed to neutralize 50 milliliters of 1 molar sodium hydroxide. So we're starting with 50 milliliters of NaOH. So to start my T-chart, I'll have 50 milliliters or 0.050 liters of sodium hydroxide. And I know that that is 1 molar or 1 mole per liter. So I'll have 1 mole on the top and 1 liter, whoops, gave you the answer there, sorry, 1 liter on the bottom. That conversion is really, really easy. I would take 50 times 1 divided by 1, and I would get 0.050 moles of NaOH. I'd move that down, and I'd do a 1-to-1 mole ratio, so 0.050 moles of sodium hydroxide. I would do my mole ratio from the balanced equation just like I would have done for mass-to-mass stoichiometry. I'm going to go from sodium hydroxide to hydrochloric acid. I can go to any of these three. I could go to sodium chloride if I wanted, or water if I wanted. But in this case, I'm going to do a 1 mole of HCl and 1 mole of NaOH conversion, and I'm going to get, whoops, sorry about that. And I'm going to get 0.050 moles of HCl. And then I know that the hydrochloric acid is 1 molar. So to finish this up, I can do my 0.050, sorry, I'm going to run out of space here, moles of HCl. And I know that it's 1 molar, so I would put 1 liter on the top and 1 mole on the bottom, 1 mole per liter. You'll notice that that's flipped from what I did in the first step, again, exactly like we would have done with molar masses if we were doing a mass-to-mass stoichiometry problem. We would have had grams on the bottom, moles on the top, and then when we finished, we'd have grams on the top, moles on the bottom, if it helps for you to refer back to that. And my answer, I'll skip over the stoichiometry part here, my answer would be 0.050 liters of that HCl, or as you could see earlier, 50 milliliters would be another way to say that. So you'll notice that the steps are exactly the same. What's changed now is that instead of doing grams per mole, we're doing liters per mole or moles per liter, and that's where that molarity piece comes in. I'll change to a different color to do the second piece here. Now we've got a slightly different question. 47 milliliters of 0.5 molar base, or sodium hydroxide, is needed to neutralize 50 milliliters of the acid. What is the concentration of the acid? So we'll do this in a similar method. We're given a volume here and a molarity of the base, or of the sodium hydroxide, so those both go with NaOH, and the 50 milliliters goes with the acid. So we start with slightly different question here. Now we're asked to find the concentration, which again, that's a little bit different, but it's still very doable with what we're doing. So we're going to start with a volume just like we did last time, and we're going to start with our 47 milliliters or 0.047 liters of NaOH, and we're going to divide by the concentration just like we did in the last step. So now this is a little bit different. We have 0.5 moles per liter, so 0.5 moles per 1 liter. Sorry, I misspoke and said divide by concentration. This is moles per liter, so we're going to have 0.5 moles on the top, 1 liter on the bottom. And when we multiply those two things together, we're going to get 0.0235 moles. Sorry, my stylus is kind of messing up on me here. Moles of sodium hydroxide. So that's how many moles of sodium hydroxide we start with. We'll then do our mole ratio, and again, that's a 1-to-1. I'll write it out just in case, but I think most of you have kind of figured this step out by now. So we've got 0.0235 moles of sodium hydroxide. We have 1 mole of the acid from our balanced equation. Whoops. 1 mole of the hydrochloric acid and 1 mole of the sodium hydroxide from our balanced equation. Sorry, this keeps skipping. And times 1 divided by 1, we're going to get 0.0235 moles of HCl. Good grief, sorry. Now this is where it gets slightly different. Now, since we don't have the concentration, that's what we're looking for, we have to do a slightly different final step. We have the number of moles here, and we have the volume in our problem. If we know the moles and we know the volume, we can fairly easily find the concentration, and you can see the answer there. Molarity is in moles per liter, so we're going to take our 0.0235 moles and put it over 0.050 liters, and that should give us a concentration of 0.47 molar, or moles per liter would be another way to think about that. So the first two steps are the same, but then we're looking for this concentration piece in our final step, so we change that just a bit to find the concentration. So your answer would be 0.047 molar. Another question here, just to give you a little bit more of a look at it. What volume of a 0.1 molar solution of sodium hydroxide is needed to completely react with 250 milliliters of a 0.1 molar solution of carbonic acid, H2CO3. The chemical reaction is there and it's balanced for you. I'll work through this one. So we're asked what volume, so we're looking for how much of this. And we know that we have 250 milliliters of a 0.1 molar solution of carbonic acid, and we're also told that this is 0.10 molar. So we'll start with what we know, which is that 250 milliliters, or 0.250 liters, and we'll use our concentration, which is 0.10 moles per liter. When we multiply that, we're going to get 0.0250 moles of H2CO3. Then we'll do our mole ratio using the number we just found, so 0.0250 moles of H2CO3. We've got a 2-to-1 mole ratio here, so we're actually going to multiply by 2 moles of sodium hydroxide over 1 mole of carbonic acid. And that's going to give us 0.05, that's a terrible 5, sorry, 0.050 moles of NaOH. And then we'll finish by multiplying by the concentration. So we're going to do our final step, which is 0.050 moles of NaOH. And we're looking for a volume, so we're going to put liters on top, moles on the bottom, and we know that this is a 0.10 mole per liter, or a 0.1 molar solution. So when we divide by 0.1, we're going to get 0.50 molar NaOH. And I'll erase this because that's where the answer is going to be, I think. But we should get 0.050, and I screwed the unit up there, I'm sorry. It should be 0.05 or 0.50 liters of NaOH. And that would be your answer for that one. Again, these steps are very, very similar to what we've been doing with the mass-to-mass conversions. It's just that we're changing it a little bit to look at molarity. This will set you up for titrations and the kind of the final capstone lab that we'll do for this unit. It also helps to apply this quite a bit better to sports drinks, as you'll see when we get together on Wednesday.